We intend to develop the leading small gas turbine engine for general aviation aircraft, and this is in the power range from 100 horsepower through to 300 horsepower, which is currently not serviced by any of the big players. We assembled a worldwide team of experts to design the components for our engine. It's an engine where the designers are not constrained by previous thinking. We have given our engineers the opportunity to look outside the box and innovate. TurbAero started about 10 years ago when I purchased the kit aircraft that needed a new engine to be fitted to it. I had a look at what was available on the market, and amongst the piston engines there was nothing that was compact enough and powerful enough to go into my aircraft. Having flown behind turbine aircraft all my professional career, I decided that turbine power was what I wanted for my own personal aircraft. We did some market research and we consulted with around about 10 of the major kit aircraft manufacturers to determine what the characteristics were that would be required to make our engine successful in the market, such as the small weight, the small size and the reliability of turbine engines. But two of the priorities that they placed were for the cost of the engine and also the fuel efficiency of the engine. Traditionally, small turbine engines have been very expensive and also very inefficient when it came to fuel. The technology that we determined we needed to reach the fuel efficiency required for the market is compact heat exchange technology. Compact heat exchange technology is technology that's emerging in the market at the moment, and it's only been achievable recently due to advances in manufacturing techniques.
Ansys has given us the ability through Workbench to couple different aspects of a problem, do the analysis, the error analysis, followed by the stress analysis, for example, or followed by the heat transfer analysis. That is what I like about Ansys and why I've chosen Ansys.
The ability to be able to simulate the components of the engines and their performance means that we don't have to use the traditional method of prototyping, testing, reprototyping, retesting. Through the use of simulation, we can save time and we can save cost by being able to simulate in the first instance and go straight to prototyping, where we expect a fairly good correlation between the simulation and the actual results.
At the end of the day, everything has to go together and everything has to work together. So we have to, at the end of the day, we have to test it. But instead of manufacturing every component, which costs money obviously and also time, we could very easily carry out a multiphysics analysis. So let's say, for example, if you're designing an impeller or a turbine disc or a blisk, we could carry out the aerodynamic analysis followed by the stress analysis. And in some cases, if you have vibratory modes that are dominant in the design, such as rotor-stir interaction. So in some cases, we do coupled aero, heat, and stress analysis. That process allows us to do multiple designs, consider different scenarios, and then pick the best one, because all these, as I said, all the disciplines are interconnected.
We have requirements to undertake simulations and analyses for all of the components of our engines, and that's across all disciplines such as aerodynamics, structures, heat exchange, and combustion. We found that the Ansys suite of software can provide the analytical capability and simulation capability required for all those areas of design.
If it gives the engineers the advantage of being able to implement ideas and sometimes out-of-the-box ideas and see if it works or not, then in that case the investors, will also benefit from the innovations that has been suggested by the engineers who are designing these components.
In selecting Ansys as our provider of software for simulation and analytics, we're going with a product that's been proven worldwide and is used by the big companies such as Rolls-Royce, General Electric, etc. for their simulations as well. This has been very useful for us in a number of ways, in that we are getting the most capable software available to us, and also when we've pitched to investors, some of the more knowledgeable have asked us what software packages we are using, and as soon as we respond Ansys, that's the end of the questioning from them, because they recognise it as a worldwide brand. Having a local experienced partner such as Leap Australia means that we can have rapid response times and quality advice when we need it. Having the right software in Ansys and having the right partner of Leap Australia has enabled us to achieve what the big guys can do.
In a small company, being able to do so many runs in such a short time allows me to put this engine together at much earlier than anticipated, and in fact almost at the same rate and maybe faster than a large company, in my opinion. I think we're doing a much better job here than a large company would have done with more resources. I think we're actually using our resources quite wisely, and we have the right tools and the right people to get there.
Here at TurbAero Nautics, we're extremely excited to be developing the cutting-edge technology that will enable us to deliver the new generation, cost-effective, most fuel-efficient turbine engine to the aviation markets. We may be a small company now, but we have aspirations to be a global leader in the provision of turbine technology to our target markets.